Vertically stretching and shrinking graphs. Let f be a function and c a positive real number. If c is greater than 0, the graph of y equals c times f of x, the function f of x being multiplied by c, is the graph of y equals f of x vertically stretched by multiplying each of its y coordinates by c. What this looks like when we're looking at a graph is if we have something like this. I'm going to draw something like x cubed. When I multiply each of my y values, if you notice, f of x represents our y values, our outputs. If we're multiplying those values by something that is larger than 1, then I get a value that is larger than the original. The value grows. So what it appears like is that my points are getting pulled further away from the x-axis. So my points are being pulled further away, and that happens in both directions. And so I end up with a graph that appears, it's a very poor graph, but a graph that appears to grow faster. It gets further away from the x-axis quicker. We call that a stretch. It's vertically stretched. If 0 is less than c is less than 1, if our value c is between 0 and 1, the graph of y equals c times f of x is the graph of y equals f of x vertically shrunk. Vertically shrunk by multiplying each of its y coordinates by c. Similar to what just happened, if our value is between 0 and 1, the y values are closer. If you multiply something by a half, it gets smaller. Our values of y get closer to the x-axis. Therefore, it looks like the function has been shrunk with regards to the y direction. All right, let's look at an example here. Use the graph of f of x equals absolute value of x to obtain the graph of g of x equals 2 times the absolute value of x. Now, I've already drawn f of x here. And here I am multiplying my y values by 2. So whereas this first point is at 1, 1, now it will be at 1, 2. I have doubled it. Now 0, 0 still remains a value, a point on our graph. Now this point at 2, 2, well, I'm doubling the y value, so that will be at 2, 4. Similarly, I get 3, 6, and 4, 8 on this graph. If you notice, rather than growing at a rate of, well, if you think about our slope, up 1 and over 1, up 1 and over 1, okay, up 1 to the right specifically, instead, because this is a 2 absolute value of x, we are now increasing by 2. We rise 2 and go to the right 1. We increase 2, go to the right 1. And on the other end of this, we have a nice reflection going on here. We have the point negative 1, 2, negative 2, 4, negative 3, 6, negative 4, 8. And there is our function, the absolute value of x, stretched by a factor of 2.